All right, one way to sort the periodic table is by their properties. And one group that you can separate them into is your metals, your nonmetals, and your metalloids. Metals make up of 80% of the elements, and they are all solid at room temperature. What I like to do is I like to remember aluminum as my key example of a metal. And why? Because I know that aluminum used to be used into electrical wires. They no longer do that because even though aluminum was cheap, which is the reason why they like to make them out of electrical or use aluminum for electrical wires, they actually would start some fires, so they are considered unsafe. But you will randomly find them in older homes where you have aluminum wires as opposed to now they use copper wiring. Aluminum also is extremely shiny. I just think of aluminum foil, and obviously if they're made into wires and they were used for electrical wiring, they are ductile, and they obviously too are malleable, which means that it can be beaten into thin sheets. That's what aluminum foil is. It's a very thin sheet of aluminum. How I remember malleable is as I always think of the word mallet, which I kind of see in malleable. And what do you do with a mallet? Well, you pound things into thin sheets. So those are various properties of metals. Now, where are they located? When you look at the periodic table, as I said, they are mostly solids at room temperature. If you look at the periodic table in the classroom, you will notice that there are 4 colors of elemental symbols. Number 1, they are black, 2, blue, 3 is red, and 4 is outlined. What those actually stand for is what state of matter do they exist at room temperature. Black represents a solid, liquids are blue, reds are gases, and outline means that they are man-made, which means that they are not found naturally on Earth and they can only be created by humans in the lab. If you look at the periodic table in the classroom, you'll notice that most of the things to the left of the periodic table are black, which makes sense that they are the solids, which makes sense that they are also the metals. So how I remember properties of nonmetals is I think of a property of a metal and I go with the exact opposite. So they are poor conductors of heat and electricity. They are not shiny. They are extremely fragile. As I stated, once again, they are mostly opposite of, their properties are mostly opposite of metals. And they also tend to be gases at room temperature. So once again, looking at the periodic table in the classroom, these would be the red ones, and those are located to the right of the periodic table. Now, what are metalloids? They are the third group that I'm talking about. So we've got metals, nonmetals, and metalloids. Metalloids are basically, if you have a metal and a nonmetal have a baby, you would basically get a metalloid. And what that means is that they have properties of both metals and nonmetals. So maybe they can conduct electricity, but they don't have shine. Or maybe they are gas, but they can conduct electricity. So they've got a blend of both metals and nonmetals property. So where are they located? What I want you guys to do is I want you to take out your periodic table. I want you to draw a line and an arrow like this and an arrow like this, and I want you to label this as metals, and I want you to label this side as nonmetals. And what that's showing is that the metals are to the left of the staircase, which we will draw in a second, and nonmetals are to the right. Well, where is this staircase? What you do is you start to the left of boron, and you work your way down and over, over, down and one, until you run out of your periodic table. So anything to the left of that staircase is considered a metal. Anything to the right is a nonmetal. The only exception is hydrogen. Hydrogen actually is a gas, so therefore it is definitely not a metal. Sometimes periodic tables actually have hydrogen drawn above the fluorine because some of the properties of hydrogen act more like a nonmetal above fluorine than it does over by the ones above lithium. All right, another way that you can classify elements is by their families. And as we've talked about before, families have a lot more similar characteristics than rows do. So one family that you're going to need to know the name of are the alkali metals. And alkali metals are extremely reactive. In fact, when they ship the alkali metals to any chemist or school, what they need to do is they actually need to ship it in oil or in an inert, which means a non-reactive gas. And the reason why is because even the moisture that's found in the air will cause the alkali metal to react and cause an explosion. All right. Why is it so reactive? Because it has one valence electron. And this one valence electron is very easily lost, meaning the alkali metals want to give up that one valence electron and become a positive charge. It's very easily lost, so therefore it's extremely reactive. Alkaline earth metals, on the other hand, only have they have two valence electrons. So even though they are also reactive like alkali metals, they are not as much because they have two valence electrons, which is harder to lose than the one valence electron that the alkali metals have. So what I want you guys to do is get out a coloring pencil or a marker or a crayon, and I want you to outline your alkali metals, which is this first column, not including hydrogen. Make sure you do not include hydrogen in that. It is not a metal and therefore cannot be considered an alkali metal. And then I want you to outline, color, whatever, the alkaline earth metals. You do whatever you need to do. You can create a key, whatever you want to do, so as long as you can still read the periodic table and know where the alkaline earth metals are and the alkali metals. And here's that metals, nonmetals thing that I was talking about earlier that I wanted you to draw. And here's that beautiful staircase that I had you draw earlier too. All right, another family that you're going to need to know are the halogens. And what halogens meant was salt forming. And what that means is actually when you look at most salts like NaCl, okay, they have a halogen in them. Cl is a halogen, and so most salts that we use, including rock salt, has these halogens present in it. So chlorides, fluorine, iodine, stuff like that. And where are they located? They have 7 valence electrons. So what I also need you to write down is that these are the most reactive nonmetals. Okay, and why are they the most reactive nonmetals? Well, they only want to gain one electron. They only need to gain one electron in order to react fully. So that's a lot easier than any ones that have less valence electrons that would need to gain more to react fully. As far as families go, the main one that you're going to absolutely need to know are the noble gases. And what are so special about noble gases is that they are inert, which means they never, ever, 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 ever react, and they are extremely stable. Why? Because they have a full valence electron shell, which means they never want to lose electrons, nor do they ever want to gain electrons. All of them have 8 valence electrons in total, except for helium has 2. So when we look at the periodic table, what I want you guys to note is that here are your noble gases in this very final column. I do need you to color that, and I also need you to box out your halogens right here. One thing I'd like you to note is that helium is considered a noble gas, whereas hydrogen is not. If you know anything about aviation in the past, blimps used to be made out of hydrogen until an event called with the Hindenburg, which was a Zeppelin or a type of blimp, actually went in flame. And what they realized is that even though hydrogen is very low density, it is very reactive and actually caused an explosion. Helium, on the other hand, it has also a very low density, but it is not reactive. Why? Because it is part of the noble gases. And remember, noble gases never, ever, ever react. And why is that? That's because they have a full valence electron shell and they never want to gain or lose any electrons. So they will never react with anything to try to gain or lose electrons. So now what did they make all blimps out of and all those other Zeppelins, I guess, is they changed it to be made out of helium so that nothing would go and cause an explosion anymore. All right, another way that you can sort them is by, it's kind of like a metal, non-metal type of a situation where you divide it into 3 groups, and that is known as your representative, transition, and intertransition metals. What is a representative metal? Well, it's kind of like your state representative is supposed to represent all of its constituents. The representative elements represent all of the various properties that an element can have. So you have the solids, you have the liquids, you have the gases, you have all the different valence electrons, you have reactive, non-reactive, you have shiny, not shiny, etc., etc. All right. They are also known as group A elements. Sometimes you'll see it written as 1A, 2A above the periodic table. That A represents that it is a representative element. If you're not a representative element, then you are either a transition metal or an inner transition metal. And what does a transition metal do? Is they act as a transition between the two sides of the periodic table that are the representative elements. Inner transition metals are the two rows that are written below the periodic table typically. They were formerly known as the rare earth elements because they thought that all those elements were extremely rare. But what they figured out or found out later is that actually some of them are very common. Now, that being said, a lot of them are not even found naturally on Earth. They are man-made, as you can tell by them being outlined. In fact, every number after 92 is man-made. But that being said, some of them that are found in the inner transition metals are very common. All right, so looking at this periodic table, I'm going to outline your transition elements. And what did I say the transition metals do is they act as a bridge between your representative elements. And where are your representative elements? Well, your representative elements are this side and this side. Those are your representatives. So the transition is a bridge between your representative elements. Where are your inner transition metals? Well, your inner transition metals are written below here. Now, if we actually were to draw a periodic table to standard or normally how it should be, we would actually include the inner transition metals right here. And if you look at your periodic table, you will note that the atomic numbers go it would go traditionally from here down to here, and then after that it would go back up to here. Why don't they include it in that place? Because if we were actually to draw a periodic table all out, it would be taking up so much space because of those inner transition metals that it wouldn't be able to fit on a piece of paper where you could actually read any of the fonts. So what they do is they take this little section out, they move it below, they move it out, and there you go. So that's one way that they separate the periodic table by metals, nonmetals, and other ways that you can sort them. You do need to know these families and the various characteristics. Have a great night.